So first, let's define what electric charge is. How can we understand an object is charged? A very simple experiment can be done. For example, if you hold a balloon near to your hair, at the beginning you are not going to observe anything. There will be no interaction between the balloon and your hair. However, if you rub the balloon across your hair, then you hold it close to your hair, you are going to observe that the balloon attracts your hair. So initially there is no attraction, but right after rubbing, you are going to observe that there is an interaction. So then if two things in the nature attracts one another, we say that they are opposite, they have opposite properties. So now, until this experiment, nobody knows about the charges. But we know that after rubbing your hair with the balloon, so balloon and hair gets opposite properties. So what are those opposite properties called? So the first, Benjamin Franklin named these opposite properties as positive and negative charges. So he said that when you rub your balloon across your hair, the charge on your hair is referred as positive. So your hair becomes positive charged, and the charge on the balloon is referred as negative. So by convention, what does by convention? Mathematically, he give a name to this charge. So we know that they are opposite characteristic. However, nobody give a name before one of them is positive, the other one is negative. So Benjamin Franklin is the first scientist who defined the charge on the hair is positive and charge on the balloon as negative. So now this is the experiment, but to understand the charging, we should first understand the structure of an atom, because the origin of electric charge is the atom. So we know that every atom contains positively charged nucleus, and electrons are revolving around the nucleus. So these positive charges which are at the nucleus never can be separated. So they can only be separated by nuclear reactions. So by rubbing or by chemical reactions, you cannot separate, or you cannot eject or remove positive charge from the nucleus. So then that's why when you rub the balloon across your hair, only the electrons are moving. Electrons are transferred from one medium to another. In normal cases, an atom contains equal number of positive and negative charges, and equal number of protons, which are positive charged at nucleon, and electrons, which are revolving around the nucleus. So there are also uncharged particles inside the nucleus, which is known as neutrons, which means they do not have electrical property. They do not have positive charge or negative charge. They have zero charge. But negatively charged particles, known as electrons, are located outside the nucleus, revolving on the orbit. Protons and neutrons are relatively fixed in the nucleus of the atom. Electrons are easily transferred from one atom to another. As I said, protons never transfer from atom to atom, but electrons, especially the electrons which are in the outermost orbit, can be transferred from one atom to another. So when an atom loses an electron, so there will be an excess of positive charge. So we can think the electron and proton cases like this. Number of electrons, or electrons are like a classroom. Think about a classroom. There are equal number of girls and boys. So say that girls has negatively charged, boys are positively charged. So then if their numbers are equal, so then we can say that this atom is neutral, equal number of positive and negative charge. But when one electron leaves this atom, so then number of positive charge will be greater than number of negative charge. That's why this atom is known as positive ion. But if the atom gains electron, in this case number of negative charge or electrons will be greater than number of positive charge. Then we say that this atom is negatively charged ion. So when an atom is charged, This atom is called as ion. So when you rub your hair with the balloon, the similar thing happens. So the atoms of the balloon, the atoms of your hair loses some of the electrons and gives this electron to the balloon. So the balloon becomes negatively charged. Your hair becomes positively charged. So in fact, electrons are just transferred from the hair to the balloon. So then, in fact, total number of charge of the system does not change. So only there is a transfer. So from balloon hair to balloon, there is electron transfer. So there is electron transfer, but total number of electrons of the system is constant. So this total number of the electrons or total charge of the system is constant is known as conservation of electric charge. What does conservation mean? If a quantity is not changing as time passes, or if a quantity is keep constant when there is some chemical or physical events, so this quantity is known as the conserved. This quantity is called as conserved. So electric charge is transferred from hair to balloon, electrons are transferred from hair to balloon, but total number of charge is kept still constant. It is known as conservation of electric charges. So if hair loses electrons, how many electrons are lost? So the same number of electrons are gained by the balloon. So then for that reason, the magnitude of the charge, magnitude of the electric charge on the hair will be the same as the magnitude of the charge in the balloon. But one of them will be positive, the other one will be negative. Hair will be positively charged, balloon will be negatively charged. But their charge in number, in magnitude will be equal. So in your book, there's a question. It says that when a rubber rod is rubbed with wool, the rod becomes negatively charged. What can you conclude about the magnitude of the wool's charge after rubbing process? Why? So we know that when you rub the rubber rod with the wool, so rod becomes negatively charged because wool gives the electrons to the rubber rod. So then if the rubber rod is negatively charged, so the wool must be positively charged, and their magnitudes must be equal. Their magnitudes must be equal because total charge of the system will be constant. What is this called? Conservation of electric charges. So when an object is charged, its charge is always a multiple fundamental unit of charge. What does it mean? For example, you can transfer one electron from, let's give an example like the balloon and your hair. So when you rub it, your hair loses electron and balloon gains. So 1 electron, 2 electron, 3 electron, 4 electron, 10,000, 100,000, billion of electrons are moving from hair to balloon. But this charge transfer can be multiple number of electrons. What does it mean? 1 electron, 2 electron, but not 2.5, not 2.1, not 3.1. So because you cannot divide the electron. So 1 electron you can transfer, 2 transfer, 3 transfer, but not 1.2. You cannot divide the electron. So that's why the total charge of a substance can be multiple number of electron. So this is known as the quantization of the charge. When a physical quantity is quantized, you are going to see this expression in the 12th grade too, quantized. You will understand this quantity has integer number, which means it can be 1 electron, it can be 2 electron, it can be 3 electron, 4, 5, 6, 7, 8, 9, 10. But not between them. So then this physical quantity is charge. So electric charge is quantized because any substance can gain a charge which is multiple number of electrons, or another substance can lose the charge, which is again multiple number of electrons, but one of them gains, the other one loses. So then one of them gains a negative charge, so gains negative E, negative 2E, negative 3E, or the other one loses charge electrons, so becomes positive E, positive 2E, positive 3E, and so on. So then magnitude of the charge on an object can be calculated by number of charge transferred or gained multiplied by charge of an electron. So then you can calculate the total charge of that substance. If you write an equation for this, the magnitude of the charge on an object is Q is equal to number of charge transferred, gained or lost multiplied by charge of one electron. So what is charge of one electron? Charge of one electron is 1.6 times 10 to the power negative 19 coulomb. So this number is very important. Also, you are going to see this number more frequently in the 12th grade. Okay, so this is a section review question, which is page 179. Question number 3. A typical lightning bolt has about 10 coulomb of charge. How many excess electrons are in a typical lightning bolt? So excess electrons means this lightning bolt is negatively charged. Even if the number is written here not negative, we will understand, yes, this is negatively charged, because generally the magnitude of the charge is written not positive, not negative. So magnitude of the charge is 10 coulomb. So charge of one electron is 1.6 times 10 to the power negative 19 coulomb. So we will calculate the number of electrons in this lightning bolt. What is your equation? Q is equal to N times E. Total charge is equal to number of charge multiplied by charge of one electron. So divide by E because you are going to calculate Q. So N will be equal to Q divided by E. Q is 10 coulomb. Charge of one electron is 1.6 times 10 to the power negative 19. So if you divide this number, you will calculate the number of electrons in this lightning ball, which is equal to 6.25 times 10 to the power 25 electrons on this lightning ball. So now next title is Conductors and Insulators. So why a substance is conductor, why a substance is insulator? For example, when a balloon and your hair are charged by rubbing, only rubbed areas become charged. So there is no tendency for charge to move into another regions of the material. Only the rubbed area of the balloon becomes charged, but other surface, other side of the balloon will be again neutral. Why is it so? I will explain later. First, in contrast, when materials such as copper, aluminium, silver are charged in some small regions, if you charge a very small region, the charge readily distributes itself over the entire surface of the material. So then, these materials in which electric charge move freely are called conductors, such as copper, aluminium, and the rest. So most metals are conductors. So then, for a conductor or a substance is a conductor, if you charge very small surface of that material, then but charge can easily distribute all around the surface of that substance. Then this substance is conductor, because in conductor electrons can move from one atom to another and can distribute all around the surface. But in insulators this is not possible. In insulators charges cannot transfer or move from one atom to another. That's why only the rubbed surface becomes negatively charged, but the rest of the surface of the balloon becomes neutral. So materials in which electric charge do not move freely are called insulators, such as glass, rubber, silk, plastic. So these conductors and insulators important not only for 11, for 12, because we are going to study the semiconductors in the 9th chapter of 12th grade. So which is the substance which has the electronic property between conductors and insulators. So then if we know what conductor is, if we know what insulator is, then we can understand, very easily understand what semiconductor is. So methods of charging. How can we charge a substance? We can charge a substance by two ways. One of them is just we learn by rubbing. You rub the balloon with your hair, or you rub balloon with your hair. There will be a charge transfer between the substances. One of them becomes positively charged, the other one becomes negatively charged. So the first method is to bring two objects into contact and let charge transfer. This is the basic idea is this one. You can rub them, or you can touch one substance to another. A balloon and hair becomes charged when they are rubbed together. This is one example. But if you hold the rubber rod with an insulating handle and then you rub it with the wool fur, the rod attracts a charged glass rod and repels a charged rubber rod. So both insulators and conductors can be charged by contact, charging by contact. So now, if a metal is charged, for example, a copper is charged, but another one is uncharged. When you touch this one, charged one to the uncharged one, so there will be a distribution of the electrons, or the charge will move from one substance to another. It's called charging by contact. Another one is charging by induction. So charging by contact can be for both insulators, like balloon and hair, also for conductors. So if you touch with a charged copper to uncharged one, so charge is transferred from one of them to another one. So it's also possible charging by contact for both insulators and conductors. But charging by induction is another method. Charging by induction only available for conductors. What does induction mean? When a conductor is connected to the earth by means of a conducting wire, or it can be a copper wire, the conductor is said to be grounded. So what does grounded mean? The earth can be considered to be an infinite reservoir of electrons because it can accept an unlimited number of electrons. What does it mean? If you connect an object, a substance, a conductor to the ground, this conductor becomes neutral, which means equal number of positive and negative charge. Why? Because earth is neutral, which means earth has almost equal number of positive and negative charges. So then, charging by induction. So conductors can be charged by induction is this. When a conductor is connected to earth by means of a conducting wire or copper wire, the conductor is somewhat grounded. The earth can be considered to be an infinite reservoir of electrons because it can accept an unlimited number of electrons. Now, this is the conducting sphere, which means a copper sphere. As you see, this is a model. This is not a real picture. So as you see, here is equal number of positive and negative charges. As I said, this is model because positive charge at the center of the nucleus, but negative charges are revolving around the nucleus. So here is positive and negative charges are distributed evenly, or homogeneously everywhere. So this is a model. This represents a neutral atom. So consider a negatively charged rubber rod brought near this neutral conducting sphere that is insulated. So there is no conducting path to the ground. So as you see, this is not in contact with the ground. That's why it keeps its charge. When you brought this negatively charged rod to the close to one side of this conductor, these electrons, this negative charge on the rod, repels the electrons on this sphere. Why on electrons? Because we know that only electrons can jump from atom to atom in a conductor. Positive charge keeps their places because positive charges are in the nucleus and they can never move. So electrons move one side, accumulate here. But when they leave their places, other side becomes positive charge. So then we say that this sphere is polarized. This sphere is polarized. This polarized. One end is negative, the other end is positive. Then if you ground this opposite side of the negative charge of this side to the ground, what does it mean? Everything in contact with the ground becomes neutral. If it is neutral, here is equal number of positive and negative charges. That's why I didn't write here positive and negative. Here is neutral, but other side still keeps positive. Why? Because still I'm keeping the negatively charged rod here. So now after that you cut the connection. When you cut the connection, still this side of the sphere keeps neutral, but other side becomes positive. Then get this negative charge away. When you get it away, influence of the negative charge rod is removed. Then the positive charge, which is initially on the left side of the sphere, is distributed around the sphere evenly. So now initially the sphere was neutral, but now by induction we didn't get in contact. By inducting with a negative charge rod, I can make the sphere positively charged. This method is known as charging by induction. Induction means you are not going to contact the object with the surface of the conductor, and you can charge it by this way. So if the wire is wired to the ground is then removed while the negative charge rod is held in place, the conducting sphere is left with an excess of induced positive charges. So this is the method of charging induction of conductors. But insulators can also be charged induction, but in a different way. So charging by induction is also possible for insulators, but in a different way. How? A process is very similar to charging by inductions in conductor takes place in insulators. In most neutral atoms or molecules, the center of positive, this is the key idea, the center of positive charge coincides with the center of negative charge. So now I'm going to draw a model of the atom. Right here at the center, which is the nucleus, there are positive charges, but electrons are revolving around the nucleus on the orbits. So then this is electron, this is another electron, everywhere electron. So the center of the electron here, center of all electrons are here, center of all protons are here. So their centers coincide. But in the presence of a charged object, for example, you rubbed your comb with your hair. You comb the comb with your hair. After that, you hold your come close to the water, close to the paper, so it pick up some paper. In the presence of a charged object, it's your comb. These centers may shift, yes. So what happens? The atom, initially their centers coincide, then becomes like this. So positively charged center will be here. So because this negatively charged comb pulls the electrons to the other side, one side of the atom becomes positively charged, the other side of the atom becomes negatively charged. So atom polarizes here, not the substance. That's why all the atoms becomes, when for example if you brought a positively charged object close to paper, this positively charged object polarizes atoms so that close side becomes negatively charged, the farthest side of the atom becomes, close side becomes negatively charged, farthest side of the atom or molecule becomes positively charged. So then this positive charge attracts this negative charge. That's why the paper sticks to the comb. So comb causes atoms or electrons to be polarized, to gain poles. One pole of the atom or the molecule becomes positive, other pole of the atom or the molecule becomes negative. When an object becomes polarized, it has no net charge. As you see, we didn't transfer any charge. We only we changed polarization of molecule or polarization of atom. However, in here, in the charging by induction of the conductors, we transferred electrons from substance to the ground. Here is no charge transfer. Here is only polarization of atoms or molecules. So then this is the charging by induction of an insulator. So now next title is the Coulomb's law. Coulomb's law explains how two charged object or two charge interact one another. So if a charge two charges are kept closer, for example positive and positive like charges, they repel one another. Negative and negative, they repel one another. Positive and negative, they attract one another. So if two charge close the other, they will attract or repel one another with an electric force F. These forces are action-reaction forces, which means they are equal in number, yeah, magnitude, yes. Are they opposite in direction? Yes. Are they on different charges? Yes. Action-reaction pairs. If one of them exists, the other one must exist. If this is exist, that must be exist. So, because force is a vector quantity, you must treat this force according to this information. The electric force between two objects, two charge object of force, always acts along the line that connects their centers of the charge, the center of the charge. You are going to draw a line. So if they both are positive, they will repel one another. If charges are negative, they will repel one another. If one positive, one negative, they will attract another, but on the line which joins their center. How can we calculate the magnitude of this charge? By equation. F is equal to K times Kc, magnitude of the charge of the first particle, magnitude of the charge of the second one. I said magnitude because when you are making calculation, don't put here positive and negative charge. One of them can be positive, the other one can be negative. Always you are going to write the magnitude of the charge because you use the negative and positive while determining the direction of the force. So that's why when you are calculating the magnitude, never write here negative, never write it, always write it positive. Q1 times Q2 divided by square of the distance between charges. It can be written R or sometimes it can be written as D. It depends on the choices in your book. It is written by R. That's why we put here R. So then F is equal to K times Kc times Q1 times Q2 divided by R squared. What is Kc? It is a universal constant, which is known as Q9 times, sometimes it's given 8.99 times 10 to the power of 9 Newton times meter square, Coulomb square. So question. A balloon rubbed against denim against a charge of 8 microcoulomb. Yes, microcoulomb is the unit of charge. Microcoulomb is 10 to the power of 6 Coulomb. So what is the electric force between the balloon and denim when the two are separated by a distance of 0.05 meter? So when you rub the balloon and the denim, one of them gains negative charge, the other one gains positive charge. So one of them is negatively charged, the other one is positively charged. In this case, one positive, one negative. Equal in magnitude, they will attract one another with a force which on the line which joins the center of these charges. So then distance between the charges given as 0.05 meter. So calculate this magnitude of this force. It's equal to K times Q1 Q2 over R squared. K is 8.99 times 10 to the power of 9. So what is the charge of the particles, which is equal to 8 times microcoulomb? 8 microcoulomb is 8 times 10 to the power of negative 6 Coulomb. So microcoulomb, 1 microcoulomb is equal to 10 to the power of negative 6 Coulomb. Don't forget this is very important. So because we are going to write the positive for magnitude of the charge, even if it's given negative, so positive 8 times 8 becomes 8 squared. 8 times 10 to the power of negative 6 squared divided by the separation between the charges 0.05, which is equal to 340.4 Newton. It is the force. The force acting on this charge or force acting on that charge, both are equal in magnitude because they are action-reaction forces, opposite in directions, and acting on the different charges. So Coulomb's law applies exactly on to point charges or particles or to a spherical distribution of charge. When applying Coulomb's law to spherical distribution of charge, use the distance between the center of the spheres. What does it mean? So charge can be very small or charge can be very large. In this case, if it is large, you are going to get the distance from the center to center. So it is the separation of the charges. If one positive, one negative, or one of them positive, the other one is positive. Okay. So now this is the Coulomb's law. Here's a practice problem in your book, page 182. It says that two identical conductance spheres are placed with their centers 0.3 meter apart. So then their centers are 0.3 meter apart. One is given a charge of 12 times 10 to the power negative 9 coulomb. So Q1 is 12 times 10 to the power of negative 9 coulomb. Other is given as a charge of negative 18 times 10 to the power negative 9. Negative 18 times 10 to the power negative 9 coulomb is the second one. So find the electric force exerted on one sphere by the other. Okay, very easy. Use Coulomb's law for calculating electric force because the spheres are opposite in sign. They attract one another. One of them is positive, the other one is negative. They attract one another. But with what magnitude? Use the equation F is equal to Kc Q1 Q2 divided by R squared. Q1 12 times 10 to the power negative 9. Q2 negative 18, but because we are going to write the magnitude of the charge, I write here positive. Positive 18 times 10 to the power negative 9 divided by separation between charges 0.3 squared. So then when you do this calculation, answer becomes 2.16 times 10 to the power 5 Newton. So then part B says that if the spheres are connected by a conducting wire, what happens in this case? If you connect spheres by a wire, so then charge flow, there will be a charge flow because conductors, when you connect to opposite charge conductors, they become equilibrium established only in 10 to the power negative 6 seconds. Quickly, charge distribute all around equally. So if the spheres are connected by a conducting wire, there will be charge exchange between the spheres until both spheres gains equal charges. According to conservation of electric charge, what does it mean? So total charge before contact and total charge after the contact must be equal. Before contact, total charge is Q1 and Q2. Q1 and Q2. But after contact, charges are equal in number, in magnitude, Q and Q. So then Q1 plus Q2 will be, in this case, 2Q. Q1 is this. Q2 is negative 18. How? You can ask me, teacher, why we wrote here is negative 18? Don't forget, we are going to write only magnitude in this equation, not here. Here, if it is positive, you are going to write positive. If it is negative, you are going to write it negative. Positive 12 times 10 to the power negative 9 minus 18 times 10 to the power negative 9 is equal to Q plus Q, which is 2Q. If you do this calculation, 2Q is equal to negative 6 times 10 to the power negative 9. So then Q becomes divided by 2, divided by 2. Negative 2, 3 times 10 to the power of 9 coulomb. So now, after connecting these two spheres, contact by a wire, both becomes equal, gains equal amount, equal sign of charge. And even magnitude. Negative 3 times 10 to the power negative 19 coulomb. Negative 3 times 10 to the power negative 19 coulomb. So then they will now, both are negative, repel. But initially they were attracting each other. After connecting them with the wire, they start to attract, they repel one another because they have the same charge. After contact, both spheres have equal charges. Negative 3 times 10 to the power negative 9 coulomb. Because both spheres have like charges, they repel each other with an electric force of the magnitude. Now calculate the magnitude by this equation. Kc Q1 Q2 over R squared. Kc Q1 Q2 are equal in magnitude. For that reason, I'm going to get squared this. Divided by separation between them. Answer becomes 9 times 10 to the power negative 7 Newton. So Coulomb's law also applies when more than two charges are present. So then, in this case, if there are more than two forces on a charge, you can calculate the resultant force. So the resultant force on any single charge equals vector sum of, vector addition of individual forces exerted on that charge by all of the other individual charges that are present. This is an example of the principle of superposition. No, what does it mean? So you are going to learn about this. You are going to hear this superposition term in the 12th grade so many times. When you add two vector, so this the mathematical method or geometric method you are going to use called as superposition, principle of superposition. For example, 3-point charges Q1, Q2, Q2 lie on x-axis. So x is equal to 0, x is equal to 3, x is equal to 5 centimeters respectively. Q1 is at origin. Q2 is at 3 centimeters, Q3 is at 5 centimeters. Calculate the magnitude and direction of the electric force on each of the 3-point charges. Q1, Q2, Q3. So just I'm going to find the force acting on one of them. Okay, so Q1 is at the origin, 0. Q2 is at 3 centimeter. Q2 is at 3 centimeter, Q3 is at 5 centimeter. So we located the charges on the x-axis. So then these charges interact one another because there are how many charges there are? 1, 2, 3. So if there are 3 charges, on each charge there will be 2 forces. If there were 4 charges, on each charge there would be 3 forces. If there are 5 charges total, they interact one another, there would be 4 forces acting on each charge. Now there are 3 forces. So then if there are 3 charges, there on each charge there will be 2 forces. Why? Q1 and Q2, they will interact one another. Both are positive. They repel one another. So Q2 repels Q1 with a force. I am going to say this force is F12, the force on 1 by 2. So Q1 also repels Q2, the force on 2 by 1. 2 and 3 interacts with one another, but one is positive, the other one is negative. They attract one another. So second one is attracted by third by F23. Third one is attracted by 2 by F32. And also 1 and 3 interact each other. So one positive, another one is negative. So then if they're positive and negative, they attract one another. So 3 and Q3 attracts Q1 by F13. And Q1 attracts Q3 by F31. These action-reaction forces, F12, F21 action-reaction forces, they are equal in magnitude. F23, F32 action-reaction forces, they are equal to each other in magnitude. F31, F13 equal in magnitude, so the action-reaction forces. Now when you calculate one of them, you know what is the magnitude of the other one. For example, let's start with this 2. Q1 and Q2. Q1 and Q2. They have a force F12 and F21, which is equal to Kc Q1 Q2 divided by R12, distance between 1 and 2. So now let's write this. Q1, Q2, distance between them, 3 centimeters, 3 times 10 to the power negative 3, negative 2, square of that number, 90 Newton. So we know this is 90, that is also 90. Now, at interaction between 1 and 3, 1 and 3. So, Q1, Q3 over R1, 3 squared. Q1, Q3, all are given. Divided by separation between them, 5 centimeter, 5 times 10 to the power negative 2 squared. Force is 43 Newton. So now, I want to find the force acting on the one of the charge. Calculate magnetic direction of the electric force on each of the 3-point charges. Now I'm going to calculate just one of them. The rest you can do on your own. So I will find the force acting on the first charge. So how many force on the first one? F12, F13. So then F12 and F13, did I calculate them? Yes. Then I'm going to use principle of superposition. Principle of superposition is what? I'm going to add them in vectors. So I will add them in vectors, but these vectors are in opposite direction. One of them is in positive x direction, the other one is negative x direction. The sum of them will be in this case F net, F12 minus F13. So if I subtract them, I can calculate the net force or the resultant force acting on the charge Q1, which is equal to 90 minus 43, which is equal to 47. You can also apply the Coulomb's law for charges which are not on the straight line. In fact, the method is the same. However, mathematical way is a little longer, so you should apply the resolving vectors into components and the method of superposition in this one. So if you want, you can check it, the solution from the document which is uploaded in the internet.